I'm Jeannette Yen. I'm in Atlanta, Georgia. I'm a professor in biological sciences at Georgia Tech. My background is in oceanography, so in environmental science. And in that area, I collaborate with a fluid physicist. So I'm a biologist collaborating with a fluid physicist, and I have always enjoyed this cross-disciplinary collaboration. So I moved to Georgia Tech in 2000, and then in 2005, I decided to open up a center for biologically inspired design at Georgia Tech because there were so many professors here who use nature as their template for their research. So we got all together. And one of the big things that our center focused on is education. So I teach this junior seniors at Georgia Tech, a course called Bio-Inspired Design, which is, I'm just getting ready to teach it online tomorrow. So I can hardly focus on this meeting, but in any case, in the class, I have 5 different disciplines: biology, mechanical engineering, materials science, biomedical engineering, industrial systems engineering, and design. So the intent of the course is to teach the kids how to collaborate between disciplines, but the outcome is to an innovative and creative design based on bio-inspiration. So over the years, since 2005, by teaching all these super smart undergrads at Georgia Tech, we figured out a methodology for teaching the practice of bio-inspired design, and that is what I teach now. So I have a specific series of steps that I use to teach this mixed group of kids, smart ones. You know, they're junior seniors. They come in, they already know, have majored in their areas. So they come in with confidence in their area of mechanical engineering or biology or material science. And I ask them, can you share your knowledge? So I put them in interdisciplinary groups, 1 from each discipline. So they may know their own discipline, but they have to tell the other kid, oh, I don't know much about what you do. So they have to admit some level of ignorance, which I think is actually humbling. Because the students at Georgia Tech are pretty, think of themselves as very sharp, which they are, anyway. So I want to know the state of the art in the field on how to teach the practice of bio-inspired design. Not just give inspiration, oh wow, the lotus plant is able to, it has super hydrophobicity, and that led to many, many patents on surfaces. But I want to say, I teach them, how do you research the biological literature for the superlatives in nature that are ripe for translation into design? And then that's the beginning. The first third of the course is just teaching them how to research the biological literature for superlatives. The middle part is how to translate those superlatives into a design. So I ask them to do functional decompositions of the organism so that they know exactly how the organism is able to achieve, you know, super hydrophobicity or whatever it is that they do. And then in the last third, I'm trying to do prototyping, but because of COVID, I can't get the teams to aggregate in the makerspace. So I have to think of at-home projects. And Julian has sent me a really good homework set for them to do some materials testing at home. And these are the kinds of things I'm going to try to incorporate in the last third instead of getting the teams to get together. Because I don't think COVID's going to be up by the end of the semester in November. So I still have to do it remotely. That's me.